Alright, class. Welcome to the second half of Chapter 11 and your final video for MAT222. Congratulations for making it this far. So in this video we're going to look at combining functions and finding their inverses. Okay. So first let's look at combining functions. So first of all, what do I mean by that? Basically we're talking about functions of functions. Okay. Sounds big and scary, but let's look at a simple example. We have the cost of something. Let's say it costs us 5 units, or it costs us $5 for every unit we sell, and we've got some fixed overhead cost of $25. And we've got a revenue, we sell every unit of something for $9, for example. Well, then we have our profit, P of X, which is equal to the revenue minus the cost. So we've got 9x minus 5x plus 25, which goes to 4x minus 25. Okay, so here we've got a function of functions. In general, we can add, subtract, multiply, and divide functions like this. It's no different from anything we've done in the past. It just sounds scarier, but it's no different than dividing two rational equations like we were doing before. Okay, so we have done this. We're just specifically talking about the case where it's functions. So I'm not going to go into too much more. I'm not going to go into even more detail about this because you've done all of this already. Okay, so that part's straightforward. This where it gets a little bit more tricky is when we start to look at compositions of functions. Okay, so here we've got this symbol f, and it's sort of open dot, or it's a small o, something like that. It's a very small circle. This implies composition, okay? And basically what the composition is it's f of g of x, okay? So this is a little bit confusing. So an example, let's say I have two functions, f of x equals 3x minus 2, and g of x equals x squared plus 2x. I want to find FOG, or find the composition of f and g. You'll kind of commonly see it like this: f of g of x. Sorry, garbage can driving by. So f of g of x. So what we want to do is, in f of x, we want to substitute g of x every place we see an x. Okay. That's a mouthful. It's easier if I just show you. So basically what I've done is I've taken g of x here and substituted it in for x right here. Okay? And so we end up with 3 times g of x, or x squared plus 2x, minus 2. Now we can simplify it, and we get 3x squared plus 6x minus 2. And now we've just got another equation that we know how to solve straight away. Nice and easy. The only tricky thing here, the only confusing thing here, is this substituting g of x for x here. Okay, but once you do it a handful of times, it'll make perfect sense to you. Okay, those same two equations. Now we want to find g of f of, instead of x here, we want to find it evaluated at the point x equals 3. Okay, so it gets a little bit more confusing. One way you could do this, and I actually highly recommend this, but I'm not going to show you here. What I always recommend for these kinds of problems is to solve the equation generally. Pretend that this equation actually asked us, is it, g, to find g of f of x. That way we have a general equation. One reason that's nice, just from a lazy point of view, is that in homework we're often asked to do something for 2 or 3 different points. So if you find the general equation, then you can just plug in numbers more simply as opposed to doing all of the work twice. Okay, I'm going to kind of do a halfway way here. So first that should be in g of x, substitute f of x for x. So again, a mouthful, but in g of x, we've got this x squared here. And now we're going to, everywhere we see an x, we're going to substitute this f of x. So here we've got x squared, and there we're going to put in 3x minus 2. Got an x here. We're going to put in a 3x minus 2. Okay? Now, everywhere where we see an x, we're going to replace it with 3, just like we would do any function. Basically, we've got our equation right here. Now we're just going to substitute in our numbers. I would, in general, recommend simplifying this a little bit more, but you guys know how to do that at this point. So everywhere we see an x, we're going to replace it with a 3, and then we're going to simplify it and find a number, 63. Okay. So again, the only tricky part here is substituting f of x in for the x values of g of x. Okay, so hopefully that is making sense to you now. Okay, now we want to look at finding the inverse of a function. Okay? The inverse of a function is found by simply switching x with y and y for x. That sounds trivial, and it is if you have a bunch of points or something like that. It becomes much more tricky if you have an equation. Okay, but just looking at our simple example, here we've got a set of points. We've got x values, and we've got y values. We're just going to swap them. So now our y values will become x values, and those corresponding x values will become their y values. So f inverse, the inverse of f of x, is equal to 101, 202, 303. So we've just swapped x for y and y for x for each one of these points. Okay? That should be very straightforward. One thing to note is that this negative 1 up here, this f to the negative 1, does not read as an exponent. So it's not 1 over f. Okay, so this is just a notation thing. I know we're sort of duplicating notation, but it should always be sort of straightforward. When you see this f of x, just know what it's, this is referring to the inverse. So it's a little bit tricky. Unfortunately, mathematicians aren't always so creative. Okay, but what about when a function has two x values with the same y value? Okay, so the opposite of that is not possible for a function, right? If we have a function, a single x value has a single y value. But it is not necessarily the case that two different x values, we can still have a function that has two different x values, but that share a single y value. Okay? Let's look at another set of points. We've got 1, 200, negative 1, 200, and 0, 0. Maybe this is something like a parabola, right? Where we've got a positive and a negative value of x that share the same y value. If we find the inverse of this, we should immediately notice that we no longer are left with a function. Okay? So the inverse of the function is not itself a function. This type of equation is said to not be one-to-one. Okay? Basically, a function that is one-to-one is first of all a function, and then the second part is it only has a single y value. Every single y value corresponds to a single x value. Okay? So this would eliminate things like parabolas. Okay? There's a test for this which I didn't write out, but it's called the horizontal line function, or a horizontal line test, where basically if you have a function plotted out, if you can draw a horizontal line, it should only cross the graph one time. Okay? So that would tell us whether or not our graph is, our function is one-to-one or not. So in this case, we cannot actually define the inverse of that function. Okay, so hopefully that all makes sense. You'll look a little bit more into that in the book. So let's look at how we actually solve for the inverse if we're given an equation. So we're given the function f of x equals 2x plus 1. The way we go about doing this is we first of all, let's just go back to our original notation. Let's set f of x, let's call that y. and let's rewrite that. So now we've got an equation y equals 2x plus 1. Now we want to swap x and y. So every place where we see an x in the equation, we're going to call that y. Every place we see a y, which should hopefully only be one time, we're going to call that x. Okay, so now we can rewrite that as x equals 2y plus 1. And now we solve for y. Okay, so in this case we get y equals x minus 1 over 2. Okay, good. So now we found the inverse, and because this is just a straight lines are always 1-to-1. So we know that this inverse actually exists, or is actually a function, and is 1-to-1. Okay, and so now we go back and we go back to our sort of function notation. We rewrite this as f inverse of x. So f inverse of x equals 1/2 x to the minus 1, something like that. Okay? Good. So that should all be fairly straightforward. This is a nice simple example. It gets trickier as you have x squareds and x's and things like that. So this can get very ugly very quickly. So there's a lot of material we've covered this week. So I highly recommend going through these chapters and looking at this chapter and going over a lot of the sample problems in there. Okay. Good luck. You guys have done a great job throughout the class. You've made it a long ways. Okay. If you did 221, you've covered a ton of material. Even just 222, we've covered a lot of material this class. So feel free to go back and watch these videos. I hear you all laughing, and get yourself more familiar with some of that early stuff, because that's you're gonna kind of build on it throughout this class, and you don't want to forget any of the old things. So great job, and keep up the good work with your other classes.